Welcome back. In this video, we'll be working step by step through the Week 4 CAD guide. As always, for access to the slides, just click the link in the description. This week, we'll be working on a part that's a little basic, but will give you some good practice for the fundamentals of using Inventor. So, without further ado, let's get started. Now, we're going to be doing a steering wheel, which is a pretty complex part as far as these CAD guides go, so this might be a pretty long video. Just feel free to look around at the dimensions, pause if you need to, or skip ahead if you already know what you're doing. So, let's take a look. First sketch, we're going to go ahead and get started. It's a pretty basic revolution kind of sketch, so I'm just going to go out and do it step by step. So this first one is 20 inches up. So I'm going to scoot out a little bit. There we go. And then it goes 5 inches over, 5 inches down. And then I'm going to come from the other direction. Let's zoom a little better. So I'll go 5 inches over and 10 inches up. And so for this arc, there are a couple different ways to do it, but probably the best way to do it would be to do a 3-point arc. And so when you hover over it, it tells you that you can do the 2 endpoints and then adjust the radius. So that's exactly what we want here. So we'll pick these two, and then we can say it's 4 inches radius. And just like that, we're fully constrained. And we can go ahead, zoom out, and revolve. So it's a pretty easy part so far, but now we're going to be doing a sweep. So if you remember from last time, the sweep will require 2 different sketches. So we'll be making our first sketch. So because all the planes have disappeared, if I click Start 2D Sketch, I won't be able to start it on one of the original planes. So I have to pick one and make it visible. And now I can edit it, or create a sketch on top of it. And so we're going to use one of my favorite tools in Inventor. It's function F7. It'll cut the part so that you see it as if no geometry exists on top of the sketch. And then I'll use project geometry to show this geometry here. And then there are a couple ways to do this, so this is just the way that I choose to do it. If I make a line here and make it a construction line, then I'll be able to snap onto the center. So I'm going to go ahead and click center, and we'll go out 12 inches. And then again, with these arcs, there are a couple different ways you can do it. You could create circles and then trim them down. Or you can make, let's see here, I believe what we want is a tangent arc. For some reason it's wanting to go there, which is odd, so I'll just mash escape key. There we go. Yep, and we want to set the radius as 5 inches and the angle is 90 degrees. And then I tried this earlier. You can't use tangent arc again because actually I don't really understand why, but we'll use center point just to give you another example of how to use arcs. So we got to pick the center, then the 2 arc points. So we'll go 90 degrees. And now we can define this dimension here as 5 inches. And it's still not properly constrained, and you can drag it around to see why. It's because it can still rotate. So the constraint that I'm going to choose to use is to make a horizontal constraint, sorry, a vertical constraint between these 2 points. And that fixes it up just right. So now we'll finish setting up the sweep. So if you remember, we need a second perpendicular sketch. So what we will do is we'll make this invisible and then the perpendicular plane visible. And then we'll go over to work planes over here and we'll create an offset from plane. So we can choose a plane and then say how far out from we want. So we want to do 22 inches, which just so happens to be this length to the end point here. So we'll go ahead and start a sketch here on this plane. And then to save ourselves some trouble, we'll project geometry of this arc so we can easily reference that point where it ends. Yeah. And it'll be a diameter of 3 inches. And so now we can do our sweep. So we'll pick the sweep command. It automatically selects our profile, and then we'll simply pick this as the curve. We'll hit OK, and boom, we have a single arm. And now we'll add a work axis to the center of this part here. And we can create a circular pattern of this sweep. And we'll make 3 of them. For the purpose of keeping this clean drawing, I'm going to go ahead and turn these visibilities off. So I'm just right-clicking and then unchecking visibility. So now we need to make a circle on one of these arms. So we're going to find the plane that intersects with an arm, like this one. And we'll make it visible, and then we will start a sketch on it. And again, we'll project geometry so that we can reference this shape. We'll go ahead and make it the same size. And as soon as we finish sketch, all we have to do is click Revolve. Now something that I think may happen, oh, there we go. And when we select our work axis, then it'll create a revolution. Earlier when I tried this, the work axis wasn't working, and so I had to go into the same sketch as the circle and create just a little construction line to serve as my axis. But as you can see, it works perfectly. And now we have something that looks a lot like a wheel, but it can be made better. So let's do some touch-ups. We're going to make some chamfers here, and we're going to pick the just general distance chamfer and make it a distance of 2 inches. And then we'll create some fillets to round it out real nice. And that will be a distance of 1 inch. And then we'll do some more fillets. It's best to do fillets in groupings, but not put all the groupings together. For example, I could have selected all of these fillets in one go, including the center, and then tried to adjust the radius, but when it comes to going back and editing things, it's best to leave them as separate features. So we'll make this 2-inch radius. And then we'll do another chamfer at the base of each of these arms. And that'll be 1 inch. And then finally, we're going to create a wheel spinner. It can be called a Brody knob. It's something so that you can turn this wheel with only one hand. So we're going to go ahead and create a plane on the bottom. So let me make this work plane visible, as well as this work axis. Okay, and if I ever need to refer back to those work planes and axes, I can always go to the feature tree. And if I hover over them, then they'll get highlighted so I know where they are. So now, how are we going to make a plane that goes straight through this wheel? Well, on this work plane drop-down, again, we have a ton of options. Like most things on Inventor, there are a bunch of different options that'll help us do what we want. And so here we'll do midplane of torus. And a torus, for those of you who don't know, is essentially a donut. It's just a fancy word. So we'll create a sketch on this plane. And we want to be careful about our orientation, just in case things don't end up how we expect them to. So it's a 5-inch square. And again, I'm going to use F7 just to make things simpler. And then I'll dimension things to the origin. And then instead of typing in 13 again, I'm going to click on this one because I know that it's going to be a square dimension. So if I ever want to change this distance of 13, I don't have to edit it twice. So we'll go ahead and extrude this square that we did. But on this, if you look closely, we're not using one direction or even the reverse direction. We're using a symmetric. So it's going to be doing 1 inch total. So it's a 1/2 inch up and 1/2 inch down, but actually we'll be doing 3. The last option would be an asymmetric, but in both directions, so I can choose how many inches in either direction. It's very useful. So we're going to be doing now a fillet to round out the square bunch. And this will be a radius of 3 inches. And now this last part can be a little tough. We're trying to make a plane that goes straight through this shape here. And there might be a couple different ways to do it. Here's the way that I chose to do it. So we're going to go to this drop down and we'll choose a 3-point plane. For those of you who've taken multivariable calculus, you'll know that all a plane needs is 3 points. So we'll choose this point here, and this point here. And all of a sudden we have a plane right in the middle. Now if you look at the slide and my work, you'll see that it's not exactly the same, but in a second you'll see that it doesn't actually matter, because we're going to be creating a revolution right on the top of this shape here. So we'll make a sketch on this plane, and then F7, let's make it easier to see. And then to interact with the center of this shape, because the cut doesn't actually exist, I'm going to put a line. Oh, I made a rectangle. I'm going to put a line right at the top here. So now that I can interact with the center by snapping to it. And so it'll go up 3 inches. It'll go over 2.5, down 1, over 1.5, and then down 2 to the bottom. Now I should have a full face here. Yep. And then all I have to do is select my axis and we have a knob. Super easy. And then finally, just to clean things up a little more, is we'll make these fillets, and you'll see that the fillets don't actually appear because a 3-inch radius would be incompatible with this shape. The shape is too small for a 3-inch radius, so we'll make it 0.5. And you'll see this is perfect. And then for convenience, again, I'm just going to turn off the visibility on these work planes. So last we're going to do just a little bit of property stuff. So if I right click on my part, we can look at eye properties, and we're going to go to the physical tab, and I can change the material to something else. So we'll change it to aluminum 6061. And as soon as I do that, you'll be able to see that it has updated several different properties. I can find the mass, area, volume, moment, or rotation of principle if you're in dynamics and are familiar with those terms. You can find centers of gravity. It's really useful, especially if you're going to be creating stuff in the real worlds that you need to know this stuff for math. And you'll see that actually between the slide and my information, it's a tiny bit different. I believe it may be a result of me making a slight mistake somewhere, or it could be that a different update of Inventor changed the properties just a tiny bit. You'll see the density is the same. But maybe the way that Inventor does math has improved. I'm not really sure, but they're pretty close, so I wouldn't worry about it too much. So we can just go ahead and hit apply. Changes the color a little bit too, which is kind of fun. But yeah, you guys have successfully completed this steering wheel, and it looks good. Congrats, and we'll see you next week.